The points A and B have coordinates 3k minus 4 minus 2 and 1k plus 1 respectively, where k is a constant. We're told that the gradient of AB is minus 3 over 2, and we're going to use that information to show that k is 3. So we know how to work out the gradient between 2 points. It's the change in the y coordinates divided by the change in the x coordinates. So the change in the y coordinates, I'm going to do k plus 1, take away the minus 2. That's going to be divided by the change in the x coordinates. It's going to be 1, take away the 3k minus 4. I'm using brackets here to be super careful with these negatives. Now let's just tidy that up a little bit then, because we've got the minus 2, which is going to simplify to be a plus 2. So k plus 1 plus 2 is k plus 3. On the denominator, we've got the 1 minus 4, so that's 1 plus 4, which is 5. And then we've got the minus 3k. So this is my expression for the gradient, and we're told that this is equal to minus 3 over 2. I've now got an equation to solve, so I'm going to cross multiply. So I'm going to times both sides by 2. And I'm also going to times both sides by the 5 minus 3k. Expanding out the brackets. Add the 15 to both sides, and I'll subtract 2k from both sides. And k is 3, as we needed to show. Now I know k is 3, I can come back to these original coordinates and actually work out what they are. So if k is 3, that second coordinate is 1, 4. Because the k plus 1, the 3 plus 1. And the first coordinate is 3 times k. So 3 times 3 is 9. Take away the 4 is 5. And the y coordinate is minus 2. So I know those two coordinates of A and B now. Which is going to be useful for part B of the question, where it says to work out the equation of the line through them. Well, I know the gradient of the line through them. So I can straight away write down y equals minus 3 over 2, x plus c. I was told the gradient here. And I'm going to substitute in either point A or point B. I think point B is probably slightly easier. There's no negatives there. So the y coordinate is 4, when the x coordinate is 1. The minus 3 over 2 times 1 is just minus 3 over 2. And then if I add that to both sides, I find that C is going to be the 4 plus 3 over 2, so that's 11 over 2. So my answer is y equals minus 3 over 2x plus 11 over 2. And I can leave my answer like that for part B. Part C finds an equation of the perpendicular bisector of A and B, giving our answer in the form of ax plus by plus c equals 0. So perpendicular bisector is the perpendicular line that goes through the middle, goes through the midpoint. So let's first of all work out the midpoint of points A and B. So let me just copy down A and B. This is point A. This is point B. So their midpoint, let's look at the x coordinates first of all. What's in the middle of 5 and 1? Well, it's 3. Or alternatively, you could do 5 plus 1 is 6, divided by 2 is 3. Then what's in the middle of -2 and 4? Again, you could use the formula, you could add them together and divide it by 2. Add those two together, you get 2, divided by 2 is 1, which hopefully makes sense. 1 is in the middle of -2 and 4. Anyway, we've got our midpoint. We now need the perpendicular line. So I'm thinking negative reciprocal. The gradient of AB was 3 over 2, or -3 over 2, sorry. So the perpendicular line is going to be the negative reciprocal of that. So it will be positive 2/3. It's going through the points 3, 1. So the y coordinate is 1 when the x coordinate is 3. The 2/3 times the 3 is just going to be 2. So C is -1. So the perpendicular bisector is y equals 2/3 x minus 1, but we can't leave our answer in that form. We have to have it looking like that. So we'll times each side by 3 and subtract 3y from both sides. And there we go.